The focus of this podcast is to show visual representations of all of the different options for the intersection of planes. We're starting with the first screen, which shows an example of coincident planes. In this instance, what we have are planes that effectively have the same algebraic equation, and therefore the same normal, the same distance from the origin, and these planes are coincident. The solution to the system of equations for the intersection of coincident planes is in fact the equation of any one of the planes, which are all the same. In other words, there are an infinite number of solutions. All points contained within the plane are the solution. We're going to now move to an instance where we have got parallel planes. In this case, what we have is a visual representation of three planes, and each of the planes are parallel to the other, and they're all a different distance from the origin, resulting in a no solution to the system of equations of the three planes represented. Similarly, if we have a system of two equations with three unknowns, graphically this shows itself as two planes, and in this case, if those two planes were parallel, we would have the same example minus one of the planes. The next option for us in terms of intersections of planes would be parallel lines of intersection, and so each of the three planes intersects the other two, but the lines of intersection of each of the planes are indeed parallel to each other, and this again algebraically will yield an instance where we have a no solution to the system, because we do not have any values that simultaneously satisfy all three equations, or another way to look at it, we do not have any points which lie on all three of the planes at once. We also have, when we have the intersection of two planes, which is known as an underspecified system, the other option for those planes is, as should be obvious from this diagram, the intersection of those two planes in a line, and those are the only two options, one of the two options for intersection of two planes. That would be coincident planes intersection in a line, and of course then no solution where they would be parallel. The next option for intersection of three planes would involve those three planes intersecting in a common line, and so hopefully it's fairly obvious from this representation that each of the pairs of planes intersect the other in what is a common line, and once again we have an infinite number of solutions to this system. All points lying along the line of intersection serve as solutions to the system of three equations with the three unknowns. The final option would be where each of the pairs of planes intersect the other in a line, and those three lines of intersection in turn intersect in a single point represented over there, and this is an instance where the system has a unique solution. It will produce one x, one y, and one z value, and those coordinates of that point of intersection represent the unique solution of the system of equations.